As we've gone further and further into this unit, Unit 0 that we're in right now, we've really seemingly been doing a bunch of random examples. But I want you to think of this as almost a pencil drawing that we're going to fill in later with color and details. There is a point to all these examples that we're doing, but you kind of haven't seen them all together yet. And that's at least part of what we're going to do today, is we're going to write a program that actually uses two of the big ideas we've been seeing over and over again in this unit. One of those being, how do we work with graphics? And the other one being, how do we use this idea of an abstraction or a class in Java? You might have noticed I'm actually working in a new project. There's a Java Intro 2 project either on Schoology or linked below this video. So go ahead and download that zip file and open it up in BlueJ if you haven't already, and we can go ahead and get started. You'll notice there's a bunch of new programs in this project, including one new Java class, which is called thermostat. Let's go ahead and actually make an instance of the thermostat class just so we can see what sort of things I can do with a thermostat. So let me go ahead, click on it. Let's make new thermostat. I'm going to call it therm. And it looks like I have to choose a min and a max value. Let's set the min to be maybe 50 degrees. We're assuming Fahrenheit here. Let's set the max to be 90 degrees. And there we go. There's my instance of a thermostat on my instance shelf down here. Just to remind you of the metaphor we've been using, remember, a class is like a cookie cutter. It shows us the template for what a thermostat should be able to do. And my instance is like I've stamped a cookie out of that cookie cutter. It is one particular thermostat, and let's see what that thermostat can actually do. It looks like I can get colder, I can get warmer, and I can actually get what value the thermostat is at. You'll notice that making it colder and warmer are both void methods, meaning they don't actually give me anything back. They just change something about the thermostat itself, whereas get value should actually give me a number. Let's see what the value of the thermostat is. It's at 70 degrees. Great. Let's go ahead and make it a little warmer. Maybe it's a little cold in here. I'm just going to warmer this a couple of times. And let's get the value. Oh my gosh, it's already at 76. Wow, that's way too hot. Let's make this colder and colder and colder. And let's see what it is now. 73. That's a much more reasonable temperature. Notice that when I use any method of the thermostat class, you can see up here it says therm.getValue. This is that process of using instance.method that we've seen before. We're going to need to do this every single time we want to use a method of the thermostat class. Now, what we're going to do is we're going to combine together the idea of a thermostat, this abstract class that somebody else has written, with a graphics program. Now, I can't just add a thermostat to my graphics board because the thermostat is an abstract idea. It doesn't have shapes and colors and things like that, but we're actually going to make these interact together in a really nice way. You might be wondering, what's another way I can see all of the methods of the thermostat class? Remember, if you actually open up thermostat and up here change this drop down to be documentation, you can actually see all of the methods written out of the thermostat class. There's colder, get value, and warmer. Now let's go ahead and put all of these things that we've learned together in one kind of big bizarro program. And to do this, let's actually talk about the different topics that we've seen through these graphics programs and console programs that we've been working with. I would argue that we've seen pretty much 5 big things. In graphics programs, we've seen events. We've also just overall been always doing decomposition. Oops. We've seen a whole lot of loops, both for loops and while loops. We've been using constants a whole bunch. And lastly, we've been using abstractions or classes. So we're going to use all 5 of these things actually in the program that we're about to write. Let me actually show you what we're going to do. To start, let me get rid of the therm. So sad. And let me show you actually the completed version of what we're about to make. Here it is. Oh my goodness, what is this? This is called the ThermoScroller. Now you'll notice that on the screen I have this kind of blue button here, and I have this red button here. I also have this label that's just scrolling across the screen. You'll notice that if I mouse my cursor over the label, it'll turn pink. Now, of course, oh my goodness, we just looked at the thermostat class. What would you guess would happen if I click on the blue or the red? If I click on the blue, look at that, my temperature actually goes down. And if I click on the red, look at that, my temperature is actually going up. So you can see what's really powering this in the back is this abstract idea of a thermostat. Now, let's actually look in the ThermoScroller program. Weirdly, my ThermoScroller program is actually hidden kind of down here. So I'm going to go ahead and let's open this up. You'll notice that right off the bat, I'm actually given two constants to work with. Something called box size, which I think should be fairly straightforward. Both that red and that blue box were box size by box size, width and height. And then this thing called border. And let me go ahead and actually run the completed version again. Now this border is actually how far every individual item on the screen is from the edge of the screen. So this distance here, that's border. This distance, also border. Same thing here and here. And actually the distance of this label from the bottom of the screen is also border. So we're going to use that constant to actually represent the distance between kind of the edges of the screen and each of the elements I'm going to be adding. Now, oftentimes as we've been writing programs, we've kind of started out doing everything in the run and then maybe we've decomposed it later. That's not actually what you're supposed to do. So let's actually start out this program by starting with a method called setUpVariables. Remember, we made a very similar method in the bouncing program, and what is the purpose of this method is to set up the variables we're going to need in this program. So let's do public void setUpVariables. Now, what variables will we actually need? Well, it seems pretty clear that I'm going to need two grecs and a glabel. So let's do grect blue box equals new grect. Where actually is the blue box? Remember, this top left corner is the x and y coordinate. Isn't that just going to be border and border? And we already know the width and the height of this box are actually just going to be box size, box by box, oh gosh, size. Maybe let's make the screen a little bit bigger. There we go. Easiest question I'm going to ask all year. What color is the blue box? It's blue. Blue box dot set color to color dot blue. Blue box dot set filled true, and let's add blue box. I think we have two more things to make. Let's do grect red box equals new grect. Now you'll notice that the red box is on the far side of the screen. We said this distance here is the border. So isn't the coordinate of the top left corner the entire width of the screen minus a border and then actually minus an extra box size? Now you might notice we don't actually have a constant for the width of the screen, but if you remember, I can actually just do get width minus border minus box size. And then the y coordinate is actually also still just border. Let me go on the next line just to make it a little easier. And I'm still box size by box size. Again, one of the easiest questions all year. What color is the red box? It's red. Box.set color, color.red. Let's also fill it in. And let's add it to the screen. Now we've got one more thing to do, which is this glabel. So let's make that glabel label equals new G label. Now there's a couple questions for this. One being, what text actually goes in this G label? Now you'll notice on the screen it says temperature equals 50. Where is that 50 coming from though? Is actually this idea of a thermostat that we're going to add in just a second. Now we don't quite have that yet, so let's just do this. Temperature equals 50. And for now, let's put this at x equals 0, and y coordinate is actually, isn't it the entire height of the screen minus border? So let's do get height minus border. And let's just add a label for now. Great, we've set up our variables. Now let's actually get that label moving. Remember, we've often used something called an animation loop to do that. So let's make a method that will animate. Let's do public void animation loop. And what do I actually want to do in here? Well, if you remember, our animation loop is just a continuous animation. It's actually something that repeats forever. So I'm going to use that really special loop that we talked about, while true. Remember, the name for this is an infinite loop because it will go for an infinite amount of time. And what I really want to do in here is move the label. Remember, I can type label dot, and what could possibly follow this dot is actually any method of the glabel class. And in particular, there's one called move. Remember, this takes two numbers. The first one is movement in the x direction, and the second one is movement in the y direction. Do I want to move in the x direction? Yeah, I think I do. Do I want to move in the y direction? No, I don't think so. So I think this will be, for now, let's just do 1, 0. Remember, we have that issue where our computers actually go pretty fast. So if we want to be able to see this movement, we're going to also need a pause command. Just before this, let's add in just a pause 10. Now, right off the bat, we're still going to get an issue when we try to compile this. And oh my goodness, we've seen this error before, undeclared variable label. So what do I have to do with label? Right now, label lives in setup variables, but oh gosh, my animation loop also needs to see it. What am I going to do? I'm going to not declare it inside setup variables, but I'm actually going to make this a global variable. Let's do glabel label. Now this can be seen by every method. Great. Let's see what this looks like. So I'm going to compile this. I'm going to close out of the finalized program. And let's actually go ahead and run this version. Oh, beautiful. Look, there we go. Our boxes look good. Our label's moving on the screen, but oh no, what's actually going to happen when it goes off? It's going to be gone forever. Let's go ahead and fix that. Remember, this is kind of similar to what we did in the bouncing program, except instead of kind of reversing the velocity when it hits the side, I actually really just want to teleport the label over to the other side of the screen. So let's do this. Remember, if I type label, if I type label dot, what could possibly follow that dot is any method of which class? glabel. And one of the methods of glabel is getX. That gives me the x coordinate of the label. If this is greater than the width of the screen, doesn't that actually mean that my label has traveled off the right side of the screen? What do I want to do? I actually want to, again, teleport the label back to the front. If I do label dot, any method of glabel, there is one called set location. And where do I want to set the location to? Well, kind of 0 and the same y coordinate, right? Label dot get y. The y coordinate shouldn't actually change. Let's see what this looks like. I'm going to compile this. Let's quit out of it if it's running. You're going to compile and run it. There we go. There goes my label. It's moving across the screen. There it goes. There it goes. It's going to go all the way off. And then boom, it's on the other side. Now that's not super satisfying to look at. If you actually remember what the completed version looked like that I showed you, it didn't just kind of appear on the other side of the screen. The label scrolled on to the left side, which looked a little bit nicer. Now, how can we do that? Why is it kind of popping on like it does in this sudden way? It's because I'm actually setting the coordinate, the x coordinate of the label, to 0. Remember, that's the coordinate of kind of right below this t here. So instead of 0, what can I actually do here? Well, we've actually seen before you can use negative coordinates to set x and y positions to start something off of the screen. So let's do this. Minus label dot get width. Again, what does get width do? It probably gives me the width of the label in pixels. And let's see if that solves our problem. There we go. There it goes. It's going towards the edge of the screen. Is it going to scroll off and on nicely? And there it is. It's beautiful. I think that's much nicer to look at. Now that our label moves nicely, there's one more thing we had to do. If you remember in the final version, when I moused over the label, it actually changed colors. To do that, we had to add in a special method called mouse moved. Let's do that right now. Public void mouse moved, mouse event. This is very similar to what we did in the mouse tracker program. So I'm probably going to have an if statement here. Let's do if. Remember that special command we used last time we were doing these mouse events if I had touched the label? There's a fancy way to do that with a special method called getElementAt event.getX. That's the x coordinate of where the mouse click happened, an event or the mouse movement, .getY, that's the y coordinate. If that's the label, then we want to do label dot. What could possibly follow this dot is any method of the glabel class. One of them is setColor to color.pink. And then let's do an else here. We're going to do label.setColor to color.black. And let's just see what this looks like. Let's compile and let's run it. There we go. It should look the same as before, except now when I mouse over this, oh look, it turns pink. Yay! Very exciting. Now we've basically made this whole ThermoScroller ignoring the thermostat completely, but now it's actually time to face this abstraction that we know is going to be somewhere in here. And where does this come in is actually with these two buttons, and specifically when I'm clicking on them, something should happen. So let's do this. Let's add in a method. Let's add in public void mouse clicked mouse event. Now, what am I clicking? It's either going to be the blue button or the red button. How do I tell that I've clicked one of those is also with getElementAt. So let's do if getElementAt, same thing as before, event.getX, where the click happened, event.getY. If that equals blue box, you're going to see right off the bat I've got a problem here. Oh no, blue box is undeclared. If I scroll up, we can automatically see what's going on. It's been declared inside setup variables. Let's actually move it to be declared out here. I always like to get rid of this first so that I don't accidentally double declare. And you could probably guess there's going to be something going on with the red box as well in a second, so let's just do both of them up here. So I'm going to get rid of where it says grect, so I'm not declaring them inside setup variables. It's going to get mad at me for a second, but we'll quickly make it okay. Blue box and grect red box. All right, there we go. Now I've made those global, so I should be able to see them in here. Now the question is, what should actually happen when I click the blue box? Well, it should make the temperature go down. And that's where this idea of a thermostat comes in. I need to use this abstraction. Right now, my program doesn't actually have a thermostat. So watch what I'm going to do here. I'm going to scroll up to set up variables, and I'm going to write thermostat therm. We did this before on the instance shelf. Now I'm just doing it in code. We've done this a bunch of times in console programs. Now we're doing it in a graphics program. How do I actually make a new thermostat? Is I have to say this equals new thermostat. And if you remember, I actually have to give a thermostat two numbers when I make it, a low or a min value and a high or a max value. We're going to make this one go from 0 to 100. It's a little crazy that your thermostat would be able to get your room down to 0 degrees or up to 100 degrees, but we're just going to roll with that. So now I have this thermostat in here. Again, we're adding in this abstract idea of a thermostat. That's how we think about this. Now I can't say add therm, and that's because this isn't part of my graphics world, right? It's an abstraction. I can't just add it onto the felt board. That's not how that works. So what I have to do is I have to make my graphics elements play nicely with this. If I say therm dot here, what could possibly follow that dot? It should be any methods of the thermostat class, which I think the three methods are colder, warmer, and get value. Now, what we really want to happen is, shouldn't this label here actually reflect the temperature of the thermostat? So let's do this. Let's do label dot set text. Let's do temperature, oh gosh, I can't spell, equals. And how do I get the current value of the thermostat? Is it not therm dot get value? Now, one thing I want to note here is that just putting this line of code in does not mean that my thermostat and my label are magically linked somehow. If my thermostat changes value, will my label change? No. Every single time I need my label to change numbers, I actually need to do this line again so that it updates based on the current value of the thermostat. You can think of this as the label is going to be a picture of what the thermostat is at this moment in time. If I don't do another label.setText though and the thermostat is changed, the label will not also update. If I wanted to change the label, could I do something like label.warmer? No, because warmer is a method of the thermostat class. But what I can do is if we go down into this mouse clicked, I can change the thermostat and then actually change the label accordingly. So how do I actually change the thermostat? What should happen when I click on the blue box is, shouldn't my thermostat get colder? Let's do therm.colder. Now this is immediately going to have an issue, which is that, oh my gosh, the mouse clicked method doesn't know what therm is. What do I have to do up here? I have to get rid of where I'm declaring thermostat in setup variables. And I need to add it up here. Thermostat needs to be a global variable. All right, let's go back down here. Now it's global, so it can recognize that the thermostat exists. Since I made this colder, will my label update? No. So let's make sure I have that same line, label.setText. Probably could have copied and pasted this. Temperature equals plus therm.getValue. I think here we also need another if statement, which is what happens if I click on the red button. Get element at event.getX, event.getY equals, oops, I forgot parentheses, equals red box. Then it's going to be very similar. I need to therm.warmer and then label.setText that the temperature is now the value of the thermostat at this second. Let's compile this and let's see what this looks like. Here we go. Does change color when I mouse over. And if I go down, look at that. My temperature is going down, going down, going down. And if I go up, look at that. Temperature going up, going up, going up. Now, what was the advantage to having the thermostat here? Could I have done this without a thermostat? Yeah, probably. I might have had a variable to keep track of the temperature and change that variable if I got warmer or colder, and then put that value in the label. Honestly, that's probably at some level what's happening inside of the thermostat class. But the nice thing about thermostat is I didn't have to worry about how it worked. I could just use this thing that had these methods written for me. I didn't have to worry about keeping track of a variable or anything else like that. So what's the advantage here? Is that I can just use this abstraction. This is the first time we've seen using an abstraction in a graphics program like this, but it's not really all that different than how we've been doing it in console programs so far. Let's go over that little checklist that we made at the beginning. Did we use events? Heck yeah, we did. We have both a mouse moved and a mouse clicked. Did we use some decomposition? I think we decomposed this actually very nicely. Here's my setup variables. Look at my run method. That's beautiful. Did we use loops? Yeah, we have an animation loop right here. We don't have a for loop in this program, but we do have kind of one loop powering a lot of it. Did we use constants? Yep, we've got two of them actually up here that help us lay out everything in our program. And did we use an abstraction? Yeah, of course. Lurking behind this is the abstract idea of this thermostat. So it seems like we've really kind of checked all of the things off our list. And these are most of the big ideas we've seen actually in the last few examples.